Starting to record. I'm hearing something on this. Okay, let me check my microphone. I've got a needle bouncing. I think I have a testing. All right. Who do I have? Anita, I see you have a microphone. Anita Nasir, are you hearing me?
Yes, I do.
Okay, that's fine. I'm going to mute everybody then. Okay. Let's see, the time is 10:02. The date is September 21st, 2018. This is the normally scheduled meeting of ITSE 2309, coming at you live and direct from beautiful downtown Frisco, one of the most desirable place in the United States to live, I understand, or so some polls said. And let's begin with a little bit of review. And let me bring up this guy. Make sure, let me double check everything because it's really embarrassing if I don't record. Okay, whenever I call this a creation script. Close him. Okay. The creation script, remember we use the ScratchDB. ScratchDB is whatever you named it. Doesn't matter, you might have named it Smith, you might have named it JonesDB, I don't care, it might be your name, it really doesn't matter. I named mine Scratch. Some other places I called it DB Cooper or something. It doesn't matter what you name it. And this is just a place where I create tables. I create any table I want. I can drop any table. I'm not worried about it. The AP_DB is our production database. We will begin using that when we get into chapter 5, module 5. When you get to module 5, you begin using the AP. Anytime you're just creating something for test purposes, do it in Scratch so we don't clutter up the AP database with other stuff. Now, this is not SQL code. This one does not need a semicolon. I put one there, but I just in the habit of it. This one says if. We do not have an if then else statement in SQL. It's not there. Therefore, this statement does not really belong there. The problem with it is if I try to create a table and the table already exists, it errors out and aborts the program. If I try to drop a table and the table does not exist, it also errors out, which is kind of PURDY, I think, but it just does. So this basically says if the table does not exist, if the table does exist, in other words, if that object ID is not null, drop it. So that's a test. Does it exist? If it exists, drop it. Now I can create it. These drops have to happen in the correct order. The child table has to be dropped first, because if I drop the parent table, the child table becomes invalid. Can't have that. So we drop the child table first. Then I see I don't have a go in here. A create statement should be bracketed by a go in SQL Server. Go is unique to SQL Server. Other database platforms don't use it. Yes, sir, question. I'm not going to address that on the test, because it's not SQL. This is purely for SQL Server. The question came up a moment ago does it require a semicolon? And I believe I said, no, I don't care. I typically don't, because that's not an SQL question. That's not an SQL statement. What it does, it breaks it into parts. Anytime you have a create statement in an SQL server, bracket your create statements with go. Create anything, bracket it with go. Later, it's going to be required when we create things. When I create a table, many times I will get unpredictable behavior from it later if I don't have the go in there. Sometimes it'll say, I can't find that table. Later, if you write select statements on the table or try to insert into it. Create table child. Go on before and after it. So it's in it. What it amounts to is you're putting it in its own program, because Go says, okay, stop, this program ends and a new one begins here. Okay, if we were creating variables, and we said and next semester very early on in it we will create variables. If I declare a variable and then do go, it goes away. So it's a completely different program. Now, if we create the table, it's going to persist. Okay. Questions? So I'm looking for the drops to happen in the correct order. Drop the child first, then the parent. Create the parent first, then create the child. Populate the parent first, then you can populate the child. Question?
So between go statements, the variables?
I'm getting ahead of myself there, because the question was about the variables. The variables are in the next class. We're not going to have them here. I might mention them briefly later on.
So it's not the table, it's not the column names, right?
No, I'm a variable like an integer that's in the program that I can put a value in, go back and get it later in my processing. Column names, if you think of them as variables, yeah, they're going to stay the same. If you create a table, anything that you do with create is going to persist. If I create something, I create it in the database. If I declare something, then I'm making this variable right here. But you don't have to worry about that, because we're not going to do declare in this class. Okay. So what do I have here? I have two tables. My parent table only has a parent ID. That's really all I need to demonstrate what I'm wanting to demonstrate. So he's got a parent ID. He's a char 1, just A, B, C. About as simple as you can get. The constraint says that's the primary key. We good. Okay. Now let's look at the second table. I have the go, which separates them as I should. Hello, Ann. I believe most of you know Dr. Cervantes. If you don't, be introduced. Create the table child. So what is this? This is a foreign key. So I'm telling you, when I call it parent and child, I'm saying I have a parent and then I have a foreign key, child. So I'm just trying to do that as simply as I can here. The child has a ID. The child has a foreign key, PID, into the parent. Takes me to the parent. Go ahead.
Do we have to name this C_ID or any other tables we are creating? Can it say just child, or can it say child_ID?
You can pretty much, I suggest that you have some method to your madness when you name tables and fields. I personally like it when I can look at a field and tell you exactly to which table it belongs by just looking at its name. So therefore, I prepend the C_ to all of my names. when I find one that's different, for example, the P underscore is a foreign key into another table. What table does it go to? It doesn't belong here. It goes to the table that begins with a P. I will typically take enough of the table name to where I get inside of my tables, my fields are all uniquely named. And I have a convention. You might not agree with my convention. You can try mine at first. If I don't like yours, I'll write a note. But if you're paying any attention at all to it, it's like format. If you just throw the stuff in there any old way, I'm going to complain about it. If it looks like you're trying to format your code, I might disagree, and I might say so, but I'm not going to take off points. Let's put it that way. So the constraints are primary key, child foreign key. When I say something is a primary key, what are the constraints? Help me out here.
That's unique.
Unique and? Okay. Somebody else, not null. Everybody say, not null. Not null and unique. Okay. When I say it's a foreign key, what are the constraints? Okay, I'm making it relate to a primary key in another table, and that's what happens. But I ask, what are the constraints? What does it make me do or not do? Foreign key can be null. Foreign key can't, it doesn't hurt the database if a foreign key is null. I can put a constraint on it and say not null, but that's different. It can be null. Okay, if you have one, that value must exist in the parent table. So it's okay to be null, but if you have a value there, it can't be bogus. Let's review. All right, let's go on with today. Today we are in module 6. And notice I got a little off there. Let's bring him back over. When I have a long line like that, I usually break the line and tab it over to show that it's part of the same line. Okay, and in good form, I have a go. Create statements should be bracketed in SQL Server by Go. But I pointed out that Go is not part of SQL. It's SQL Server unique. Therefore, I don't care whether you put a semicolon after it or not. Okay, what am I inserting? I'm going to insert some values into parent, A, B, and C. Good enough? Okay. Insert into child, the child ID and the parent ID. I'm going to insert the child ID is going to be X, Y, and Z. Okay with that? So the parent ID, parents are A, B, C. The child is X, Y, Z. Now, to whom does the child X belong? The parent's name is A. To whom does child Y belong? Also to A. A has 2 children. Child Z belongs to B. Parent C doesn't have any children. That's fine. Couple of other things. If I tried to insert a parent ID of D, I would get an error, foreign key violation. All right, now we can select it, look at it. Okay. If I execute this, I get that it, well, execute, and we executed successfully. Notice that we have 2 of them, ABC and XYZ, with the parents there beside them. Okay. Now, this comes from Module 6, page 1. We're talking about table joins. And basically, all of that code comes from the page. I just copied and pasted it over there and put the goes into it. Okay, let's look at this select statement. We'll come back to it. Paste. Now, you do not have to have go between select statements. select statements don't, so they're not creating anything. You only have goes, bracket with goes, when you create. Maybe some other times, but yeah, some people will put go between everything. You don't need to do that. So what does this say? Select PID. The name of this thing is primary key. That's its name. It's not a constraint. I'm saying select p.pid. Let's go on through it. C.pid as foreign key. I'm selecting from two different tables, but let's go to the from line first. Then we'll come back to that select line. From. Notice how I've put those two tables in there. From, parent, and then I gave it a name, P. The reason I gave it a name, because I hate to type. I'm a very slow typist. I always argued that a computer programmer should be a slow typist because it gives you time to think about what you're typing if you have to type with two fingers. Whether that's the case or not, I don't know. But notice I say parent as P. I've renamed parent, the table, comma, child as C. Now, we talked about the order of execution in the last class. What happens first in an SQL statement? The first line that's executed is the from line. So when I rename it on the from line, I see that rename all the way through the SQL statement. If I rename it on the select line, that doesn't happen until, so it's from gets first, where is second, select is third, order by fourth. So if I rename it on the select line, I can use that alias in the order by, but I can't use it anyplace else. SQL is strange. It doesn't happen in order. Okay, we're not going to worry about the order by. So parents as P, child as C. Select P.PID. Notice that both of those tables have a field in them named PID. If I'm going to select it, I have to say which one do I want? Which field? Well, excuse me, the field is PID from which table? I want the one that says P.PID. This one, I want the one from the C table. And I gave it a name, foreign key. And finally, I just want to see the C_CID. Because I only have one of those, and it's got to be in the child table. You with me on that? Now, let's look at what happens when I run that. This is called a table join. Okay, I'm using an old syntax here. But this is called a table join. Actually, what is going to happen here when I run this? Well, let's run it and see if we can figure out what happened. Execute. Good grief in the morning. Let me go back over here. I got what? I got 9 rows. I had 3 values in one table, 3 values in the other table, and between it, put them together every possible way. Now, let's go back over to our canvas, and let's look at them. Let me roll where I can roll it up and get the font a little bit bigger. Primary key, foreign key, CID. What does it do? It took primary key A, matched it to foreign key A, matched it to child AX. Foreign key A matched to primary key A, foreign key AY. Parent A matches to child BZ. And notice that I do the same thing. BBB matches to AX, AY, BZ. Parent key CCC matches in order to AX, AY, and BZ. So notice for each one of these, I have 3 of them and matching to every possible one in the child table. So in your own words, tell me what's going on here. Okay. Mhm. Combinations. Okay, so where order doesn't really matter to us, I can see them in any order, that is combinations. So I have 9 possibilities. Suppose I had in my tables, I had 5 values in one table and 4 primary keys. So I have 5 foreign keys, 4 primary keys. It really doesn't matter which one's 5 and which one's 4. How many rows would I have in the result table? 20. Good. Okay. And if I had 10 and 10, I'd have 100 rows. Well, what would happen if I had 1,000 rows in one table, 1,000 rows in the other? Well, that's about 1 million, isn't it? And that's what's happening. It makes every possible combination it can make. Question, please. Okay, when we take a break, when I can come back there, and the question is the copy and paste isn't running. On errors like that, follow along with me, and it's not critical that this be running right now. Just can you see what's happening? So when I join 2 tables like that, and I just put them in the from line and put a comma between them, what happens? We call this a Cartesian product. Cartesian coordinates, Descartes stuff. It makes every possible combination. So if I have 1, 2, 3, A, B, C, what would I get? I get 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. They don't necessarily come in that order. I haven't put any order. I guess I did put an order on them. But we'll see them. We'll see all of those rows. Okay. Now, I'm interested in the parents and the children. Of these rows, let's go back here. And by the way, the highlighting is important here, the highlighting I put on it. Which of those rows am I interested in if I want parent-child pairs?
The one which has parent-child together.
The ones that are highlighted in yellow, maybe? Yeah. Why those? Because the parent's primary key matches the child's foreign key. The others are just extra fluff that we don't need them. So this one, for example, row 3, the parent and the child, the foreign key in the child does not match the parent's primary key. Don't want that one. How can I throw them out? Hint, hint, where? Oh, okay. Let me go back over to my SQL server, and I'm going to put a where in here. Where what? And here's where it comes in nice that I've renamed those guys so I don't have to type the whole thing.
So did you say primary key equals foreign key?
Yes, I can't say primary key though, because I'm coming right there. Let me finish this one. I can't say primary key because primary key was defined on the select line. I can't see that on the where line. It doesn't happen until the next step. You're on the right track though. Exactly. We're going to use that alias to keep from typing. I'm going to say where, and I just usually go left to right. P, it doesn't matter, dot P ID equals C dot P ID. I must qualify the tables because PID is in both of them. Some people say, oh, Smith, you need to just name them something different. I prefer to have my foreign key named the same as my primary key. Just my preference. Some people say, no, you should name them something different, and then you don't have to qualify it with the table name. If the foreign key and the primary key had different names, I wouldn't have to do that P dot. I choose to go ahead and do the P dot, but I rename it. Okay. And now, go ahead, please.
We We can also say parent.pid.
You can also type out parent.pid if you're really macho about typing. Some people do that. And that's fine if you want to type. Once you rename the table, I believe it hides the original name. I don't think if you say parent as P, I don't think you can use parent again. At least you can't in Oracle. I don't know. Oh, crap. Well, we'll just silence this unless it's my wife. Oh, it's that. Okay. Now, when I execute this, what do I get? It bugs me that this, see, copy with headers. Now what I'm going to do is drop over here to Excel, and drop this in Excel where I can blow it up and we can take a better look at it. Come on. Paste. And center them up. Okay, now notice what I got out of that. I only see the parent-child relationships. This is what is known as an inner join. It has a newer syntax. This is the old syntax, but you'll still see a lot of this. This is where you write it like this, where you, in the from line, you just list the tables separated by commas. In the where line, you link it by the foreign keys, foreign key, primary key. Okay? This is a pre-1991 syntax of SQL. It's still in common use. It's the way I learned it. Therefore, I do it this way. No, I don't. I do it the new way. I'm going to give you the new way in just a second. It does exactly the same thing. It's just a newer syntax. Let's go look at these guys again. So the primary key A has child X. Primary key A also has child Y. Primary key B has child named Z. Note the primary key, foreign keys match. That's how they get into the relationship. What do you notice about these? What's missing? Yes, but I'm not interested in those. If the parent does, if the primary key of the parent does not match the foreign key of the child, I could care less. That's just extra. Please go ahead. We don't have parent C. Parent C does not appear in our output. That is one of the basic properties of an inner join. This is an inner join. Inner join, only records that participate in the relationship are in the output. Okay? C, if we have a childless parent, we don't see that childless parent. The other thing we don't see is an orphan. What is an orphan?
The children who are not connected to any parent.
How would that be picked out? What would that be? What would their foreign key be? Just a minute.
The foreign key would be other than X by Z.
Well, it can't be anything other than X by Z except one value. Orphan, no parent. It wouldn't match to a parent, but I can't have a D or an E or an F in there. So what could I have in there? Remember, a foreign key can be null. A null foreign key does not match to a parent. Therefore, a null foreign key in the child will not appear in the output of an inner join. Okay, this is what we call an implicit inner join. And let me bring up the code again. Everybody okay with this output? Here's the code. The code looks like this. If it's going to run off the edge, I break it and tab it. Let me blow this up. Okay. Now take a good look at the from line. Now, this syntax has been superseded. This syntax still works in all SQL implementations. If I picked up this select query, dropped it into Oracle, dropped it into MySQL, dropped it into Access, it would work just fine. No problem. But it has been superseded. There is a newer syntax. Now I'm going to give you that. This is the implicit syntax, and I will give you a copy of this file. Implicit inner join. Okay, just put them in the from line separated by commas, join them in the where line by their foreign key, primary key. Well, what would you do if you had 3 tables in the join? Can I have 3 tables in the join? Yes, I can. If I have 3 tables in the join, I need 2 links. I just put them in there with a comma, and then where the first table's PID is equal to the second key's foreign key ID, and second table's primary key equals the third table's foreign key. So it's just like putting together a train. If I have 3 train cars, I have to have 2 links. If I have 10 tables, I have to have 9 linking conditions. Just the way it goes.
Does it work with and or?
And is definitely in here. I would say table1.pid equals table2.pid, foreign key, and table2.primary key is equal to table3.foreign key. So I would have an and in there. Yes, it works with and or. Okay, here's the new syntax. These two will be the same, select the same stuff. So I'm going to call this the explicit. Explicit inner join. Select, this doesn't change anything on the select line. From parent as P, child as C. The where line, maybe you have a where line, but the where line moves down to later. I'm going to keep it in there as a comment just to say that's where it goes. And what changes here is this from parent as P. Sometimes I will skip a line, go down to the next line. If I'm going to scroll off the end of the page, I break to the next line and tab. From parent as P, inner, join, child as C, keeping the same indenting, on. Now here's the where. Remember, inside of a select statement, we do not like completely blank lines. SQL Server doesn't mind, but other platforms will, so we're not going to get in the habit of putting blank lines inside of the statement. Now, this is going to give me exactly the same output. Explicit. Notice that all of the same information is there. Select, well, the same stuff. From parent as P, but now I have the term inner join. Hope that's not me ringing again. I'll be embarrassed. Child as C, and I still have, there's the where part. I have a where, but the where does not apply to the join. It could be where the parent's name is Joe, if I had the parent's name in there. It could be where the parent is less than or equal to B. And so the where now would apply to the join, but it does not, the where does not get involved in the actual joining of the tables like it did up here in the implicit join. In the implicit join, the tables were joined in the where clause. In the explicit inner join, they're joined in the from, as just as the syntax of it, the from line performs the inner join. If I were to execute this, I'm going to see exactly the same output. Let's see, copy with headers. Let's go over here and compare it. Okay, notice it's exactly the same output. Questions? They are the same. They are identical statements. There is a reason that it changed, and I'll tell you what that reason is, why we use the explicit join. Yes, ma'am.
If you had more than 2 tables, then would you have to say inner join?
Twice, yes. Yes. We'll probably do one that has, we could create a third table, grandchild, if you like, parent, child, grandchild. And so I'll probably do that as an example later. Question?
So the statement p.pid equals to c.pid, that was the thing that got rid of all the extra rows.
It did. That was that's called the join field.
Okay, and then you said this, getting rid of those extra rows is what made it an inner join, right?
Before we got rid of those extra rows, we didn't really have an inner join. We had what we call a Cartesian product, and sometimes you do that. Logically, what happens when you join tables is, the reason I like that implicit syntax is you're creating logically you're creating the Cartesian product and then filtering out the ones you don't want. So it doesn't have to do it that way. That's the thing about SQL. We don't know what the SQL runtime support system is going to do with it. We're just specifying what the answer looks like, and then we let the system take care of it.
So my question was, if the p.pid equals to c.pid,
Okay.
if that's the thing that made it the inner join,
Yes.
why do we have to say inner join and on? Like,
Okay.
if we didn't have the on statement, wouldn't it be like clear? Because the fact that it says inner join tells us that.
Okay.
P.pid.
Question goes back to the difference between the two syntaxes. I guess that's plural. In this case, the linking field in the old syntax, the implicit syntax, which isn't bad at all. You'll still see a lot of people will use it. You'll see it from time to time. You need to be able to see it and know what's going on. When you see the old implicit, where you just separate them by commas and link them in the where line, okay? And so I say create this big Cartesian product and then go through in the where line and filter them out. Now, we're not saying that that's, in SQL, the SQL system can do anything it wants to do such that it gives you that answer. So I don't know how it's going to do it. It might create the product, it might not. It can decide how it's going to do it. I don't care as long as I get the right answer. Okay, so this one I'm specifying the answer by putting them both together like that and saying where it's equal. Now you're talking about the syntactic differences, where here we just say the select is the same, but instead of doing it as two separate lines and putting this back up in the implicit syntax, this is in the where line. All we've done is change the syntax a little bit. There is no difference. Okay? And if this were the only thing that it corrected, it doesn't correct anything. The first way isn't broken. There's nothing wrong with the first way. So just because it's an older syntax doesn't mean that you can't use it. You can. In fact, I'm going to ask you to write a table join in the old implicit syntax. And I say, write this, show these relationships using the implicit syntax, and then write it again using the explicit syntax. You need to know both of them. They are both still in use. When we get to another kind of a join, we're going to see that there was some equivocation. There were some things that I couldn't tell. I wasn't sure what to do in a different kind of join. So what happened in 1991, everybody got together and said, everybody, all the platforms are doing this differently. If you ran either of these on any database platform, it'll run. This is pure SQL, both of them. Now, if you go over to Access, for example, and you just do it using the graphical user interface, what you will see is that it will write out, instead of P, it will write out parent. So it's going to look something like this in Access. What that's doing, it puts it in the square brackets. Now the reason that's giving me a line under it is because I have renamed parent. If I take that renaming off, well, it just moved it. But what it will do, it will put the square brackets on it to allow people to have identifiers with spaces in them. Do we have identifiers with spaces in them? No. And never, never, never. Questions?
I do have a question, Professor.
What's that now? If you want. In SQL proper, the only time I do an alias is to stop me from having to type as much. So if instead of, I would have to type parent 1, 2, I would have to type parent 3 times when I can just type P.
I get it. I was just thinking of the case where I was helped to run a query for a user to get more understanding.
If you have a query and the query has a calculation in it, so select what's one we total amount due or something like that, where we take the invoice total minus the payment total minus quantity, payment total plus credit total, close parentheses. Okay, that's going to have to be aliased to be accurate, because otherwise the column won't have a name. So you just say as T, if you like. I don't get too involved in what it is. So I would, if it says name it amount due, then name it amount due. Don't name it amount space due with brackets on it, just because there is no point in it. If there's some reason you have to, and I can't imagine what that would be, then you can put spaces in the alias, I suppose. But why? Most of the time, the output of an SQL query is not going to the end user. Okay, it's going to go. It goes up to a web application, And from there, they can do any darn thing they want to with it. I just have to give them some name. They have to know what name's coming to them. And then they take that name of that field and they do any darn thing they want with it. So my SQL server, all it has to do is, I don't care if you name them X, Y, and Z. It's just, I tend to name things, I tend to be terse with my names. So PID, what does that mean? P table, primary key, ID, or PK maybe. I like names that give me some information that aren't difficult to type. And I have some kind of a convention of naming. So you may develop your own. Maybe you don't like mine. Okay. When we get into the next class, we're going to see we have identifier names all over the place. We'll have names that are variables inside the program. We'll have names that are inside of a table. We'll have other names that are inside of temporary tables. And our life will get a little confusing, which is my objective. But I try to make it unconfusing. Okay, so a couple of things point out here. The new syntax is the explicit inner join. The old syntax is the implicit. If I don't say, if I don't tell you explicitly to be implicit, how's that? If I don't ask for the implicit, the old syntax, I want you to use the new syntax. Get in the habit of using it. You can only use the old syntax if you're my age. And that's what you learned. So back in the old days, when I was taking database for the first time at University of Texas, we used the old syntax. And very quickly thereafter, it wasn't long after that, we switched to the newer syntax. Newer syntax is better because it is consistent with the next one we're going to do, which I'm not going to bring in right now. Inner join. On an inner join, the only shows you records that participate in the relationship. If the record does not participate in the relationship, it is not part of the output. I cannot use an inner join to tell you anything about childless parents. I don't know whether I have any or not. I cannot use an inner join to tell you anything about orphans. I don't need a join to tell you about orphans. All I can tell you orphans from one table. All I have to do is look at the child table where the foreign key is null. Those are the orphans. So I don't have to have a join for that. But in the join, I can't tell you about orphans. I guess I could, but it just doesn't help me any. So if it doesn't participate in the relationship, the other thing I cannot tell you in an inner join, what would happen if I had an invalid parent? Why, that can't happen. Ha, ha, ha. Yes, it can. Somebody just disables the constraint. And by the way, a constraint is like a light switch. I can turn it on and turn it off, all of them except the primary key. I can't turn that one off. The rest of them, if I want to put a null value into a table that is constrained against null, I just issue one little command that says, oh, ignore that constraint for now. Turns it off. Then I can put null values in there. Then I can turn it back on. Now you got null values in the table. I can say ignore the foreign key constraint. Now I can put bogus parents into the child table. Turn it back on again. Yeah, that happens. Okay. People will not do that foreign key constraint correctly, or they will just leave it off. Suppose they just left it off completely. There's no foreign key. Would the join still work? Absolutely it would. The join doesn't know anything about the foreign key. All it's looking at is do the values match. The joins would still work. You will see people will write tables and they won't write a foreign key constraint. And therefore they get invalid values in there. You see that all the time. How many of you guys have taken 1307, ITSW 1307 access? Okay, when you start that, it just starts throwing data into tables. You haven't created any relationships yet. Then you go back and try to create the relationship. What happens when you try to create the relationship and you have bogus data in the table? Error, error. Now you got to go find those bogus data. Inner join won't help you there. Okay. Inner join will work fine. It'll show you where they match, but it won't show you where they don't match. Okay. And let's see, it is about our break time. So I'm going to pause recording. I'm going to leave it on. Okay, let me turn on my, okay. Any questions from the people in Usenet land? Internet land, I mean. Let's see, if you have muted your microphone, I can't unmute you. We both have to agree that your microphone is on before it is. Are there questions? Very well, I'm going to go back to mute. I'll ask for questions again later. And I'm going to pause the recording. Okay, we've had a nice break, and so we're back to recording now. I notice I've made a few changes to the table, and we'll go through those in a minute. And somebody asked me if I were taking questions. Go ahead.
So my question is, in the homework last time, the module 5 homework, we had a series, a bunch of different select statements, and I was wondering, is it sufficient to have the use AP database at just at the very top?
Okay.
Go, and select statements all after that?
The question was on module 5, can we just have the use AP database at the top one time, and then a go, and then the select statements in order after that? And the answer is yes, that would be fine, although you do not need the go. Once you say use, the use stays in effect until you change it, even after the query executes. Therefore, you'll see that you'll get back a program from me where I've just commented out the use in yours because it didn't match mine. But when you say use AP underscore DB, you only have to say that once, and unless it changes. Then after that, you don't have to have a go because you're not doing any create. The only time you need a go at this point, and I think, well, when you have a create, you have to, you bracket it before it and after it with go. Most of the time, your create will be in a different file from inserting your data into the tables. They don't have to be, but after you create the table, you should have a go. And in between each of creating the tables, you should have a go. The use APDB will persist all the way through. Okay. Some people will put go between all of their select statements. You don't have to do that. That's, if you did it, well, you did it. It's not a big deal. Okay. I might make a comment on there. You don't have to put go. If you're not creating, you don't have to have go at this point. There might be a case at some time when you will, but I'm not going to say that's categorically true, but it's true that you don't have to have a go unless you have a create. Okay, I have created some changes to the table here. I have added a grandchild. So I have to say drop the table grandchild before I start. So if it exists, drop it. Then I create the parent. Parent's the same. Create the child is the same. Then I create the grandchild. Notice that the grandchild references the child. I don't have any direct link from the grandchild to the parent. Okay? So the only way I can get from the grandchild to the parent is go through the child table. Let's see what this would look like in an inner join. So this is going to be 3 tables. Tree table implicit, im. Okay, what am I selecting? Select. Let's see, I want the P dot let's get the child. And because the grandchild, the GID, the primary key of the grandchild, is unique, I don't have to say G dot. I just say G ID. Helps if I put a comma. From let's see, I'll just go ahead and three tables. Go ahead, please. Question.
I know we can format it at Notepad++. Can we format the query actual in the database, like the server?
I am in the I'm in the query window of the server, or you may use Notepad++, or somebody in here is using a different one.
Can we format it?
You can format it just if it comes out. You should fuss a little bit over formatting. In other words, I like to see it tabbed. For example, when you're creating a table, I like to see these tabbed in there. Can you do that? You can do that in Notepad or Notepad++. You can do it in Word if you save it as text only.
My question is, can you do it on the actual database?
I don't know what you mean. This table is the SQL batch file is just text. You can format it any way you want, or not. Well, some ways are better than others, but you're just formatting a text file. It's like, can you format a business letter in the actual business letter? I mean, of course, what else would you do? So you're formatting the SQL file. Basically, the SQL file is just text. It's just a Notepad file. And the SQL server in the query window interprets it line by line. If you write it in Notepad, save it as a .SQL file, that's fine. It'll run just fine, assuming you don't have any syntax errors. I have kind of warmed up to using this query window. Okay. By the way, if those wiggly red lines bother you, you can turn those off. It is not entirely accurate about them. Sometimes it'll make mistakes and tell you something's a mistake and it's not, and sometimes it'll tell you it's not and it will be. Most of the time it's about 80% accurate. It's helpful, I think. Okay. Go back to my query. From, notice I have 3 cars in my train. How many connections do I have to have? 2, 1 fewer. So here I'm just going to start, and when I say the where P dot PID equals child dot. And So I'm just going to keep going down through them. Now I've got to get to the other side of the child. C dot CID equals grandchild dot CID. I'm not going to bother with an order by. That is the 3 table explicit. Okay, now what will I not see?
You don't see the parent table equals the grandchild table.
Well, okay, yeah, we don't have it in there because I have no link from the grandchild to the parent unless I go through the child. I don't have that information in either table. I don't have information about the grandchild in the parent table, and I don't know the paternal.
This way, it uses that child table as sort of the intermediate.
Right.
It has to match both sides.
Yes, it goes through the child table. I'm going to see information coming from the child table. Okay, let me run this and let's take a look at it.
Wait, can we see what data you put in there?
Just a minute, and we'll definitely take a look at that. Okay. GRAND. Okay, let's look at the parent first. What's in the parent? The parent just has okay, this is the parent. Okay, now let's run the, wish there was some easy way to collapse that. Let's get the stuff from the child. And here's the child. Huh? Why don't I see more than that? Oh. Didn't copy it right. I'm not doing something right here. Copy. Okay, there's the child with the parents. And then let's see the grandchildren. Get everybody from grandchild. Copy with headers. Squeeze him down a bit. So. Okay. Now here are the data, and I have 3 grandchildren. So child X has a grandchild, child X has 2 grandchildren, child Z has 1 grandchild, numbered 1, 2, and 3. Child X is a child of parent A. Child Z is a child of parent B. Parent C has a yes. Parent C has child W, and parent D does. Parent C has child W, but W has no grandchildren, and parent D has no children. Okay. So if I link all three tables, I'm only going to see records that participate in the relationship between all three tables. I will only see the parent of child X and Z. So the only parents I should see will be parent A and parent B. So when I execute this query, okay, this one won't have order to it. So here's the query. Okay, so I'm only seeing parents A and B. If the parent does not have a grandchild, they're not in it. Why? They get into the first one. So for example, the parent and child, parent C has a child, but parent C's child does not have any grandchildren. Therefore, they are not participating in the relationship. It has to be in all three tables. If there were four tables, it would have to be in all four tables. Anybody that's not in there doesn't count. If I have an orphan parent, if I have an orphan child and that child has a grandchild, it would be legal, but he wouldn't appear in the inner join. And I'm stressing that it's inner join, and I'm going to say there is another one coming where you will see unmatched records. Please go ahead.
So inner join will never get more rows than the tables, right?
No, it'll never have more rows than the largest table. Yes. Might have fewer. Yeah. And another point to ponder about an inner join. The inner join is indifferent to order of the tables. It is indifferent to order. Let's go back to the query. So the order that I put these tables in an inner join, the order that I specify the tables in the implicit syntax is irrelevant. The order that I do this one, whether I do this one first or this one, is irrelevant. But I can't just take the C table out of it. They all have to be there, and the link has to be the same. But if I were to take this part, C.CID equals G.GID, and move it first, it would not change anything about the rows that were output. It might change an order of things that were output, and if I specifically said order by something, then I would get exactly the same output no matter how I put the tables in there, or when I say the implicit join. Now, it gets a little trickier when we get to the explicit syntax. Let me write it in the explicit syntax. This is going to be three table explicit. Okay, this is all the same down to here. No comma, child as C, usually tab, on. Cut. Okay, that's one. If you have a where, remember it's not joined in the where line like it was up above. If you have another where, I mean, I only want to see parents whose name begins with a vowel or something like that, then that's different. That goes in the where line. If I only want to see where the parent that has more than one child, I can do a count where the count is greater than one. Count of the child ID is greater than one. We'll talk about that. That's coming next. So this one is going to give us the same output. Notice that it doesn't, it's going to give us AA and B with their children. I'm not going to bother bringing that over to Excel, but they are the same rows. So these guys are the same. SQL Server does not need a semicolon. This would be okay if you put the semicolon down there. Other platforms, for example, Oracle, will need a semicolon, so I always put the semicolon. Oracle does not like spaces inside of a select statement or any statement. Spaces inside of it cause it to abort the statement. So that's why we're a little fussy just over getting into the habit of doing that. And now it will run on any platform. If I were to drop this into Oracle, it would run just fine. If I were to drop it into MySQL, it would run just fine. I could drop it into Access and it would create a query just fine.
On that, does Oracle like local tabs? Okay.
Yeah, for the most part, everything today will handle tabs in the input file. You might run into a pathological situation where it doesn't. Therefore, you can set your editor to the question involved using tabs versus 3 or 4 spaces. You can set your editor to when you press tab, it inserts spaces instead of tabs. I haven't seen one in the last 20 years that cared. Now you might think of one. I don't know what. Yes, question.
Are these like short variable names? Because is that popular with SQL? It's really different from other programming languages I've learned where they ask for long variable names.
Okay, that depends on the convention to which you're writing a program. It's just like if you write an essay and you have a handbook of style and you say, well, I want to go see lions, comma, tigers, and bears. Does a comma go after tigers? It depends on what handbook of style you write to. Do you put 2 spaces after a period or 1? Depends on your handbook of style. Do you say healthy food or healthful food? Right. Okay. So back to your question. You can use an identifier of any length. My particular preference when I program, I use terse identifiers, meaning the shortest identifier by which it will fit into my scheme, and I can look at it and get information about it. For example, a primary key, I will typically name it the first letter of the field name underscore ID or PK. When I see ID or PK, what is that? It's a primary key. FK means foreign key. I would not write FIRSTNAME in first name. I would write simply F name. To me, that gives me all the information I need. And with SQL, it's going to get verbose enough. So particularly when you get into programming in the T-SQL, Transact SQL. So I see no reason to make it longer. If you want a longer field name, go ahead and make it longer. I'm not the one that has to type it. You do.
Well, there's usually like industry standards like most will do it this way.
There are, for example, C programmers tend to use very terse, very short identifiers, whereas a Java programmer will use a longer identifier. And there are some conventions like that, but they are not set in stone. So the name of the game is what works for you. I read code very well. I do not want to see a field name like X, Y, and Z field name. So give me something that has meaning. If I see G_ID, that's from the G table and it's the primary key. That's my convention. If I have two G tables, then I take the first two letters. So if I have two tables that begin with G, one of them will be GR and the other one will be GI. The table that begins with that, underscore. Notice that all of my fields are unique. A field name does not have to be unique across tables, but I like it when they are, except for primary key, foreign key. Those I match the names. You do not have to match the name. The foreign key does not have to match the name of the primary key. That's my convention. Okay, so kind of look at my conventions now, and then you're free to disagree later on in the class, maybe. I mean, if you like a different format than I do, that's acceptable. But I want it to have some format. I want you to pay attention to your format. Pay attention to the names of your identifiers. Is there method to them? Can I read them and tell what it is? You don't have to have a long one. And if you go to work in a place that demands really long ones, then I guess you're going to have to make long ones, huh? Okay. Table explicit. Let me just check here. It's 11:30. I was going to try to maybe get out of here a little early today because we got a major rainstorm moving in on us this afternoon. I was going to try, see what I could do. This is called a cross join. I called it a Cartesian product.
That's the one with a lot of rows, right?
Yeah, that's the one where you don't have any where. By the way, if I had 3 tables in the join and all of them had 5 rows each, how many would I have in the 3-table join? 5 times 5 is 25 times, I'd have 125 rows in that join. Question?
In the implicit join where you said and, could we have put or and it will bring up all like the child which had grandchild but no parent to the child? Would it have brought up all those entries?
You would bring up something, and I'm not real sure what you'd get. It might do that, but it would not be an inner join. Right now I'm teaching the inner join. And the inner join has an and. You can try it and see what you get, see if you can explain it, and that's how you learn. The inner join is a very common construct, and the implicit join, it separates the tables with a comma, and it joins them in the where clause, and if you have more than one join field, if you have more than two tables, you're going to have more than one join, then they're separated by an and. Does not matter what order you write the join fields, as long as you get the equals correct. Doesn't matter which side of the equal it goes. It does not matter which side of the and the chunk goes. Now, if you totally mix them up, it won't work. For example, I could not say, yeah, I could not say, what is it? Here we are right here, where PID equals G.CID and try to put this one together. That would really be a mess. So if as long as I keep my things that are equal together, I can write these in either order. And I can write these guys in either order. And then if I take this as a chunk, I can put it on either side of the and. I can write these tables in any order. I start with the highest one and go down. Then when I link them, I do it the same way. Start with the highest one and go down. So there is method to my madness. There's some order that I have imposed on my writing, so I don't just throwing stuff in there. There is some order to it, even though the inner join, one of the properties of the inner join, it doesn't matter about order. And if it does not participate in the relationship, it does not appear in the output. That's the inner join. Now let me go back to my canvas for just a moment. So here's the inner join. Try it. Write a query demonstrating an inner join that returns all vendor name, invoice number pairs. Invoices, inner join vendors, or vice versa. I think vendor, yeah, I believe invoices is the child, vendors would be the parent. Don't necessarily hold me to there being exact. I believe this one is accurate. Sometimes when I give you a row count, stuff will change in the table, and maybe I've made some changes to the AP database, the data that are in there to demonstrate something later. And if it's not 114 rows, don't get your knickers in too big of a knot over it. Try it. Next. Student resources. Not okay. Here's the PowerPoints. I'm not a big fan of PowerPoints. The two things I'll never do in this, I'm not going to sit here and read PowerPoints to you. I'm not going to sit here and read you the textbook. If you want to look at the PowerPoints, some people like them. They're there. I'm not guaranteeing anything. I didn't write them. They came with the textbook, so I just put them up there. So there they are. Next. Here's the modern syntax. This is the inner join from parents, inner join child. Okay, so this is the post-1991 syntax. They are exactly the same logically. There is a reason why we changed that's going to come up in the next class. Why we changed the syntax. We changed the syntax to be consistent. But if you use the explicit, if you understand the implicit, then the explicit isn't really any different. You have the same information in there. Next. Okay. You can do an inner join of a table to itself. Type inner from invoices, inner join. A table may be joined with itself. This is pages 134 and 135. The textbook's example is okay, but I like this example better. Consider a table named employees. In this table, go with me. In this table, I have an employee ID and the employee's supervisor. Okay? It's in the table. Is the supervisor also an employee? The answer is yes. Okay, and this, I suppose, doesn't have to be. You might hire somebody from outside, but the supervisor is also an employee. So I have in there, I have the employee's ID and I have the employee's supervisor. So E-super. Now, the supervisor is also an employee. So where does the supervisor's EID? The supervisor references the same table. Okay, it's a different field. So the supervisor references the employees table, the EID field. So if I wanted to see all employee supervisor pairs, the supervisors with the employees they supervise next to them, I would join employees, comma, employees. I would have to rename them in this case. Employee as E1, inner join employee as E2, on employee E1 dot EID equals E2 dot super ID. And I would get the pairs of supervisors, employees. It's an inner join. I would not see supervisors on one side. I would not see anyone who did not supervise somebody. Okay. But if all of the employees were supervised, then I would see them. So if I didn't have a supervisor, I'm not going to show up. I'll show you that one. The self-join is in there. I think I'm going to wrap up here today. It is 11:47, so it's getting pretty close to 11:50. And so I'm going to wrap up 3 minutes early. Can I do that without destroying my reputation? I'm known for starting on time and finishing on time and giving your breaks on time, normally. I am going to try to get out of here a little early today, hopefully before the rain starts up. Okay. So we have not finished it yet, but you should be. I'm going to go ahead and assign Module 6, the exercises. I don't think I have any self-joins in there. Let me run through this thing and make sure that I don't have anything really weird in here. Multi-table joins we've covered. I'm going to cover this diagram here. By the way, I can generate this diagram over in the, if I go over View Object Explorer. In the Object Explorer, I can go to, let's see, the Scratch database. If I go to Database Diagrams, and it says that I don't have something that I need, do you want to create them? I say yes, and it creates it. Then I say a new database diagram. What do I add? Let's see, let's put the parent in there. Let's put the child in there. And let's put the grandchild in there. And notice that I can move them around. Make them bigger. Thought I could make them bigger. There. So I can see a diagram of the tables, yeah, and you can create this. You're welcome to play with this a little bit. If it helps you, that's fine. the diagram is just a graphic. Saving it doesn't do you any particular good. I just create them ad hoc as I want to see something. As I'm curious about what table is referencing what table, this will give me some information about it. So it will help me write the query. Other than that, when I'm done with it, I just throw it away. Do I want to save it? No, I don't really need to save it. I'll just create it again. The Query Object Explorer, if you get tired of looking at it, you just close it. You can always get it back. You go up to View, Object Explorer. Okay, I will save this. Save as, let's see, what is this? Create 9.7. Yeah. Documents. Okay, I want to go to Documents. Let's go to, okay, SQL code, and I'm going to call this one okay. I'm going to put this out as it'll be attached to an announcement so that you will have this file. I try to do that always. I'm going to now end the recording. Well, wait a minute. Let me ask my participants.
So you are on time again?
Say again, please.
So
Anita.
you are, yeah, you are leaving the class on time again. So no harm to your reputation.
No harm to my reputation, I hear. Okay. Any questions on, we have covered the inner join. Now you should be able to do the inner join exercises, most of them. I'll make them due probably next Friday. But
yeah, we'll do that. And if I have a question, we'll email you.
Okay, yeah, you can use the Canvas messaging, and I try to get to that right away.
Okay, thank you so much.
Anybody else? Mark, you doing okay?
Yep, thank you.
Okay. I'm going to end the recording now. The